going to take a day to review systems of equations, and we talked about this, gosh, I guess it was the first week of school when you did that Math 8 review. But I'm going to do an example of each kind of the 3 ways to solve systems of equations, so that in case you forgot, you'll have a little bit of a refresher, I guess I should say. Okay, so 3 ways to solve systems of equations. So 3 ways to solve. The first way that we always learn is by graphing. And that's when you're going to graph the 2 lines on the same coordinate plane and look for where they meet. Second way is substitution. And I actually like to call this clouds and rainbows. But that substitution is when you solve for a variable and then fill it in. So you substitute it back into the problem. And then the third way is elimination. And when we did that problem in class, I think I also did a POD, worked out a POD question for most of you that had the nickels and, I think it was nickels and quarters. And I used systems of equations to solve that one using the elimination way. So let's start with graphing. Okay, so first thing is we always have 2 lines that we're going to be working with. So we'll call this example 1, and this is by graphing. All right, so all right, let's say we have x plus y equals 7. That's going to be 1 line. And y equals 2x minus 8. We'll try that as another one. All right, so what we're going to do is graph these 2 lines on the same coordinate plane and then find the point where they meet. So first thing, in order to graph, I need to get in slope-intercept form. So we looked at doing this, let's see, I guess that was on Tuesday. So I need to get y by itself, so I need to move the x over, and I would do that by subtracting x from both sides. So I'm going to end up with y equals negative x plus 7. And then this one is already in slope-intercept form. All right, so just to color code, I'm going to do this one in blue, and then I'll change colors for the other one. So I'm going to just sketch a graph on here, and this is not the best way to do this actually at all, because this is the least accurate, and it's going to be even worse since I'm not using graph paper. But all right, so to graph this line, I'm going to start at the 7 because that right there is the y-intercept. So if I start at 7, let's just say that's 1, 2, 3, 4, 5, 6, 7. Start right there. All right, then the slope is right here, and this slope is negative 1. So that means I can go down 1 and right 1, or I can go up 1 and left 1. So down 1, right 1, down 1, right 1, and I think you get the general idea there. Down 1, right 1, down 1, right 1, down right, and then down right. So that gives me really good. So, okay, so we'll pretend that's a straight line. So that's the first line. All right, now I'm going to come through and I'm going to graph this one in orange. So I don't need to rewrite this one. This is already y equals mx plus b. So I'm going to start right here with the b, and this one is at negative 8. So if I say 2, 4, 6, 8, so I'm going to start down here. And then this slope is 2, which means 2 over 1. So I'm going to go up 2 and over 1, up 2 and over 1. And this is where it would be nice to have graph paper. Up 2 over 1, up 2 over 1, up to over 1. So it looks like I'm getting right there. So now I'm going to draw that line. Oh, I missed it totally. Oh, that was terrible. And then, of course, that one was pretty good. Oh, good grief. Sorry about that. All right, so I can now see that these two lines meet at that point right there. And that would be the point. Let's see, 1, 2, 3, 4, 5. Looks like it's over 5 and up 2. So that is the point 5, 2. So that tells me that if I graph these two lines, they meet at the point 5, 2. Out of all of the points on this coordinate plane, all of these points, that's the spot where they meet, and that's 5, 2. Now, if you wanted to check it, the easiest way to check is to just fill it back in. So if I filled this into the first one, I would have 5 plus 2 equals 7, and it does. If I filled it into the second one, I would have 10 minus, 8 equals 2, and 10 minus 8 does equal 2, because that's the 2. So filling that in gives me 10 minus 8, and it equals 2. So that one checks. So that's a review on graphing. All right, next up, we're going to move to substitution. When we do substitution, basically what we're going to do is we're going to solve one of the problems for one of the variables, and then we're going to replace it, and then solve from there. So for this one, we're going to do substitution first of all. So substitution. Okay. Let's try x plus y. No, let's do negative x plus y equals 3. And then 3x minus y equals 5. Okay, I like to call this clouds and rainbows, and I'm going to show you why in just a second. But the first thing you need to do is solve one of the problems for one of the variables. So what I want to do is rewrite this one as y equals. So if I rewrite this as y equals, that means I need to add the x over here. So I will get x plus 3. All right, now here's where the clouds and rainbows come in. So I'm going to put this in a little cloud, and then I'm going to float it and fill it in right there. Because what I'm saying right here is that y is the same thing as x plus 3. So if y is the same thing as x plus 3, then I can fill in x plus 3 anytime I see a y. So I'm going to now go to this problem, and I'm going to put 3x minus, here's my cloud, equals 5. And in the cloud, I have x plus 3. And you can see this is exactly the same, minus, but this I've replaced for the y, and then equals 5. So there's the cloud, and now we're about to see the rainbow. Because when we work through these problems, we have to distribute right there. So we have 3x minus x minus 3 equals 5. So 2x minus 3 equals 5. Add 3 to both sides, and we get 2x equals 8. Divide by 2, and x equals 4. Now, I'm not done, because remember, I'm trying to figure out the ordered pair, the point that these two lines have in common. But I have half of my answer done, so I know it's going to be 4 something. So now, to figure out that something, I can go any spot up here and fill it in. So if I go, let's say right here, and fill in the 4 for x, 4 plus 3 would be 7. All right, you could also go over in this one and fill in the 4 for the x, and you would have 12 minus y equals 5, so y would have to be 7. You could do it that way as well. But in the end, this is the point where those two lines meet. But instead of graphing, we use substitution. On this one, this is going to be example 3. So, example 3. We're going to use elimination, and the idea behind elimination, let's do negative x minus 5y equals negative 30. And let's do 8x minus 15y equals 20. Okay. So, in elimination, what we want to try and do is eliminate one of the variables. We don't know how to solve with 2 variables in a problem. We only know how to solve with 1. So what we want to do is eliminate one of them. So I'm noticing that if I multiply this line by negative 3, I will create a situation right here where the y's will cancel. All right, so if I multiply this first line by negative 3, then I will have 3x plus 15y equals 90. All right, and then this line is going to stay the same. So this will be 8x minus 15y equals 20. So what I'm going to do now is to combine these 2 lines together. So I'm basically going to add them together. So 3x and 8x is 11x. 15y and negative 15y cancel. And 90 plus 20 is 110. So to solve, divide both sides by 11 and x equals 10. But remember, we're not done because we're trying to figure out the ordered pair. But I do know that these 2 lines will meet at 10 something. So now we can go back and we can fill in whichever one we want. I'm going to go ahead and just fill in this first one, I guess. So if I fill in x with 10, I'll have negative 10 minus 5y equals negative 30. All right, now if you can't quite see this, then you just need to go through the steps. But if you add 10 to both sides, that tells us that negative 5y needs to equal negative 20. And dividing by negative 5 tells us that y would equal 4. So this ordered pair, 10, 4, is the point where those 2 lines would meet on a graph. Now, last thing we need to do is just make sure that we cover, there are 2 special cases. So one is no solution. And no solution will happen if you cancel out your variables. So cancel the variables. And you are left with a false statement. So left with a false statement. That is going to be no solution. And on a graph, that means you have parallel lines. All right, so an example of that would be if you had, let's say you had 2x plus 5 equals 2x minus 9, and you subtract 2x from both sides, causing that to cancel, you're left with 5 equals negative 9, which is not true. So this would be a no solution. All right. The other special case is infinitely many solutions. And what that means is that there is more than just one point. So infinitely many, that means that the solutions are too many to count. There's not one, there's a ton of them, infinitely many. What's going to happen there is, again, you will cancel out the variables. But this time, you are going to be left with a true statement. So if we just look at the example that we did above, if we had 2x plus 5 equals 2x plus 5, and we subtracted 2x from both sides, we would be left with 5 equals 5. And that's true. So the answer would be that there are infinitely many solutions. All right, hope that reviews everything for you, and now you can get started on your assignment.